Hello guys, congratulations for making it to Module 3, Metals and Alloys. For this lecture video, we will discuss about mechanical properties of metals. But before that, sa mga hindi po nakakakilala sa akin, I am James A. Kagumbay. I'm a registered chemist and a licensed professional teacher that teaches here in Camarines Sur Polytechnic Colleges. So for this video's objective, we will discuss mechanical properties of metal. But take note, we are not only discussing these properties for metals, because these mechanical properties also are the properties of most of our materials. So we'll just focus on the metals. But we will discuss later on the mechanical properties in general of all of the materials. So in this video, we will identify the mechanical properties of materials, and we will explain the properties of metals through its structure and bonds. So we'll be discussing about these mechanical properties, and we will describe its macroscopic properties. So let's start. So when we talk about properties of metals, the properties of metals are the characteristic by which it can be accurately identified or by which its range usefulness can be determined. Take note that the properties of metal is actually makes the identity of your material. It's the characteristic. So pag sinabi natin properties of matter or properties of material or properties of metal, we are pertaining to the characteristic ng isang material. Okay? So matigas ba siya? Anong color niya? Is it tough? Is it strong? Is it flexible? Is it elastic? So those are actually your properties. And most of your materials are known for their properties. Alam natin that aluminum is very light. Magaan siya. We all know that foam is very soft. So that's actually your properties. And take note, your properties also determine the range of usefulness of the material. For example, dahil malambot si foam, we can use it in this manner. Dahil magaan si aluminum, we can use it in this manner. Dahil strong ang iron, we can use it in this manner. So these properties actually dictates the usefulness of our materials. And sometimes we manipulate these properties so that it can be used outside sa usual ng use. Yun yung ginagawa natin usually with material science. We manipulate the properties so that we can use it in other means. So that's how we use the properties of our metals. That's why we need to really determine or identify the properties of each material that we use. So let's now go to the mechanical properties of metals or of materials. So we have 7 basic mechanical properties, and these are actually the basic ones that karamihan ng mga materials natin sa material science ay tinitest natin ito, mini-measure natin, so that we can identify your material. So we have your hardness, brittleness, ductility, plasticity, elasticity, malleability, and toughness. And we will discuss it one by one. So let's start first with hardness. So hardness is the ability to resist wear, abrasion, cutting, and indentation. In other words, ito yung kakayahan ng isang material mo para hindi siya magasgasan, putol, kundi kaya mauka. Okay, that's hardness. So kung isang material natin hindi siya agad-agad nagagasgasan, for example, platinum, or hindi agad-agad siya nang uuka, like iron, those are actually hard materials. Okay? And meron tayong mga materials na madali lang maukaan. For example, clay. Di ba? Madali siyang gasgasan. So, mababa yung kanyang hardness. Pero yung mga katulad ng platinum, titanium, and iron, mataas ang kanilang hardness kasi they can resist wearing, cutting, and indentation. So that's your hardness. So it may be a property which is uniform. Makikita nyo yung buong metal mismo is hard. Or pwede naman itong hardness na ito is depende dahil dun sa kanyang outside, yung kanyang surface. Kasi may mga times na ang ginagawa lang natin is mas pinapatigas lang natin yung surface niya. We call it actually case hardening. Pero yung sa loob, hindi talaga siya tunay na hard. And we call that actually, yes, your case hardening. Okay? And take note also, when we increase hardness, we would also increase the brittleness of your material. So they are related. Actually, these 7 basic mechanical properties are related to each other. So when you increase hardness, take note, it will also increase the brittleness of your material. So ano nga ba itong brittleness na to? We will talk about later. Pero before that, we will look into naman kung paano tinetest yung hardness ng isang material. So simple lang ang idea ng pag-test ng hardness ng isang material. Yung material mo, and we will try to press one material na alam natin yung hardness. For example, steel ball. Yung isang steel ball, i-press natin siya doon sa material. So it will create an indentation, yung uka, doon sa material. At doon sa uka na yun, will determine kung gaano ka-hard yung isang material. Or we can also use yung mga cone type. Okay, usually we use a diamond tip cone. Remember, diamond is one of the hardest material. Actually, it's the hardest mineral that we have. So pag press natin siya against the material, magkakaroon ng uka yung material, and kung gaano kalalim yung ukang yun, we can actually determine the hardness of the material. So that's how we test hardness. So talking about kanina yung brittleness, we talk about brittleness. It's a property of metals or materials which permits no permanent deformation before breaking. In other words, when a material is brittle, it breaks instantly without any intermediate stage of bending, or it lacks plasticity. Paano yung nangyari? Kasi for example, you have your material. Ang nangyayari sa mga brittle material is kapag siya ay nabigyan ng force which is enough for it para mag-break yung bonds between the molecules, ang mangyari sa kanya is instantly it breaks. Wala nang bending na mangyari, wala nang deformation na mangyayari. Let's take for example, your glass. Glass is a brittle material. Kaya mapapansin niyo, kapag binato mo ang glass or furnace mo yung glass, hindi siya madideform. Hindi mo makikita yung mauuka siya o madideform mo na siya bago siya no. Ang tendency kapag nabigyan siya ng amount ng isang amount of force, ang tendency niya is to break agad-agad without any more deformation. Kung titingnan naman natin sa plastic, sinabanggit dyan yung lack of plasticity, when you try to pull a plastic, pull it away, yung forces is away from each other, mapapansin mo, hindi agad-agad nag-break si plastic. Why? Nag-deform muna siya. So, plastic, therefore, is not a brittle material kasi it bends, not break. Okay? So, the idea of brittleness is it breaks instantly. Okay? Now, base dito sa sinabi kanina, when we increase the hardness, we also increase the brittleness of your material. So, the more hard your material is, the more brittle it is. So, that's actually the idea. Kapag ang mga tao pa-hard, they are the most brittle of all. At one who got from Sir Neil. Anyway, so the opposite of brittleness is plasticity and ductility. So we'll talk about plasticity and ductility later on. So just take in mind na brittleness is the opposite of plasticity and ductility. Okay. So speaking of the plasticity, let's talk about plasticity. Okay. So when a material is said to be plastic, if it is soft and easily deformed. So, kabaliktaran nga kasi talaga siya ng brittleness. Sa brittleness, it easily breaks without any more deforming or deformation na mangyari. So, sa plasticity, it's actually soft and it can be easily deformed. Pwedeng magbago yung kanyang shape, pwedeng magbago yung kanyang form. Okay, that's your plasticity. And take note yung deformation na nangyari sa mga plastic materials are actually permanent. So plastic materials have very little elasticity. That is, they don't return to the original shape after the deforming force is removed. So permanent yung deformation na yun. Now, usually pag narinig natin kasi yung plasticity, we are actually thinking the plastic materials, Tupperwares, yung mga plastic bags. Well, they are all plastics. They are identified as plastics. Pero there are other materials that exhibits plasticity other than your plastics. Okay? So, meron tayong mga metals and ceramics that are plastic kasi they are soft and they can be easily deformed permanently. Okay? So, and the idea is, for example, clay. Clay can be is considered clay exhibit plasticity. For example, you have a clay. Pag finesse natin si clay, ang tendency niya, made-deform siya. Okay? So, hindi siya agad-agad mag-break. Like sabi ko nga yung glass, pag finesse natin yung glass, ang tendency ni glass, like hard siya, it will be, and it's very brittle, it will break instantly. Pero so clay, hindi, made-deform lang siya. Okay, so that's actually plasticity. Okay, and take note, hindi rin siya elastic kasi hindi naman agad-agad bumabalik siya sa original shape niya. Unless, siyempre, baguhin mo ulit, reform mo ulit. Yun ang kagandahan kay clay. Kasi you can easily reform it. Okay, so that's your plasticity. Now, plastic materials are not brittle. So they are actually opposites. Okay, now, ito yung usually sinasabi ko sa mga estudyante ko, more likely as a joke. Kasi kung sinabi ng ibang tao sa iyo, ay, ang plastic mo naman. Well, ang magandang respond dyan would be, thank you. Why? Kasi kesa naman brittle ako. Getting my point? Parang ganon. Kasi at least I bend, not break. I don't know if you get the joke, but yan ang usually sinasabi ko. Kasi sinabihan ka ng iba, ay, ang plastic mo naman. Say thank you. Anyways, so punta naman tayo sa ductility. So sa ductility, this is actually deformation din, pero under tensile stress, under tension. So when you talk about tensile stress, this is the force away from each other. So yung sabihin, paghila. Okay? So this is often characterized by materials' ability to be stretched into a wire. That's why most of our ductile metals, like for example, copper, can be stretched into a wire. So usually gumagamit tayo ng universal testing machine for this one. So you have a bar of that metal, of that material, tapos ahatakin siya. Okay, that's tensile stress. The forces is away from each other. That's tension or tensile stress. Now, kung ilan yung force na may apply mo hanggang siya ay mag-break, that's actually how we measure the ductility or the tensile strength of your material. So, we sometimes use the ductility, pero pagdating sa material science, we use the tensile strength. Yeah. Now, yung kapatid na ductility is called malleability. Bakit kapatid? Kasi may kinalaman din siya sa deformation. Pero, unlike ductility, malleability is the deformation under compressive stress. So kung kanina yung tensile stress is forces away from each other, malleability is under compressive stress. Sa compressive stress naman, compress, meaning the forces is towards each other. Yung forces natin towards each other siya. So that's actually malleability. Okay? When the material can be deformed under compressive stress, when you compress it, it can be deformed, it can be actually hammered or rolled into very thin or flat sheets. That's actually malleability. That's why sa malleability, mapapansin niyo yun sa paggawa natin ng mga yero, pinapanipis natin yung mga sheets, mga GI sheets natin or galvanic iron sheets. That's actually pinapakita doon yung malleability ng mismong material, yung galvanic irons. Okay? And take note also, when a material is heated, its malleability increase significantly. Meaning, kapag ininit natin isang material, i-expect natin yung malleability ng material na yon will increase, especially for metals. That's the reason why sa mga blacksmiths or sa mga ironsmith, iniinit nila yung metal at as in very high temperature, sa kanila pupupukin with their martilyo. Saka na-hammer. Okay? The reason is, mas madali ngayon siyang ma-flatten. And that's actually application of your malleability. The deformation under compressive stress. Now, take note, malleability and ductility is the ability to be deformed. Kapag ang isang material hard and brittle, di ba, mabibreak lang yung material. That's why they are very much, they are related to your plasticity. Okay? So ulitin natin, the malleability of the material increases significantly when material is heated. Okay? Now let's talk about elasticity. Kanina nabanggit na ito. Okay? It's still deformity or the ability of your material to be deformed. Pero when the force acting on it has been removed, it will return to its original shape. That's your elasticity. Okay? Parang rubber, di ba? Hinatak natin yung rubber, pero pag binitawan natin, so nirelease natin siya, yung force, nirelease natin, and it will return to its original form or shape. That's elastic material. Pagkakaiba niya with plasticity, sa plasticity, yung deformation is permanent. Okay? So materials with high ductility and toughness are elastic. So mapapansin natin sa mga bagay, for example, copper with high ductility or very ductile na material, copper, pag hinatak natin siya, can actually go back to its original form. Okay? And nandyan din yung ating toughness. So we'll talk about later on yung toughness. So materials with high ductility and toughness are considered elastic materials. So materials which are hard and brittle have very little elasticity. Kasi when you give force, you put force into it, more likely they will break. Okay? Although it will need a lot of force. Kasi it's hard, take note, it's hard, so it will take a lot of force bago siya totally mag-break. Pero wala nang deformation mangyayari doon, it will instantly break. So, walang elasticity yung mangyayari doon. Kasi pag break na, wala na, hindi naman ibabalik siya sa original shape. Parang masakit yung hugot na yan. Anyways, let's go to the last mechanical property called toughness. So, iba ito pagdating sa hardness. Okay? So hardness, it's the ability to resist wearing, abrasion, indentation. Pero sa toughness, it is called your impact strength. So, it's a property that determines whether or not a material will break at a sudden impact. For example, yung material ko ay nahulog or hinampas ko sa another material or nahampas ng ibang material. So, ang tawag doon is sudden impact. So, yung mga sudden impact forces na yon, magbe-break ba yung material o hindi? Pag hindi siya nag-break, we say that the material is tough. And take note, malaki ang ugnayan niya with your elasticity. Kasi, usually, tinetest natin yung toughness. For example, you have a strip of material here na siya perpendicular sa table. Okay? Ang usually ginagawa natin for toughness test, meron tayong nakahang na isang material, na hard material, na kapag binitawan natin, it will collide to your material here. Ang tendency ng mga tough materials is it will bend. Okay? And once, dahil sudden lang naman yung force, hindi naman siya pressing, tulad ng ginagawa sa hardness, ang tendency ng tough material na yun is it will just go back to its original form. That's why it's considered elastic also. So tough kasi hindi siya nag-break at it can go back to its original form. That's your toughness. Okay. Now, speaking of metals, ang pinakakilalang property of your metals is called electrical conductivity. So, isa yan sa mga patunay na metal ang isang material if it can conduct electricity. Now, simple lang naman ang pagpapaliwanag actually ng electrical conductivity of metals. Dahil ang metallic band, meron tayong mga sea of electrons that can move around. So, the idea there is electricity is the movement of electron. So, pag nakaka-move yung electron, electricity can flow also. That's the idea. So, sa metallic band. Pero, ang tanong natin dyan is, bakit si insulators, yung mga non-metals natin, bakit yung mga metalloids natin na usually mga semiconductors, bakit hindi sila nakaka-conduct ng electricity? Or for the metalloids, bakit may certain conditions na kailangan abutin para mag-conduct sila ng electricity? So, that question is actually answered by your band theory. It's a theory that explains why materials can conduct electricity while others cannot. So, the band theory states that the localized electrons move freely through bands formed by overlapping molecular orbitals. So just imagine you have different, you have atoms na magkakatabi. And because magkakatabi sila, yung kanilang mga orbitals, diba? Kung saan umiikot yung mga electrons, kung saan gumagalaw yung mga electrons, nag-overlap na yun. Okay? Because of this overlapping of electron orbitals or molecular orbitals, nagkakaroon tayo ng mga bands wherein doon gumagalaw yung mga electrons natin. To illustrate it further, ito yung itsura niya. So you have there, for example, magnesium metal. Okay? Magkakatabi siya, tapos yung mga orbitals niya, nag-overlap din. And because of that, meron tayong tinatawag na valence band at saka conduction bands sa ibabaw. So yung valence band, nandiyan yung mga electrons nasa valence, yung mga valence electrons natin. Kaya tinawag siyang valence band. Talking about valence electrons, these are the electrons na nasa outermost shell. So that's your valence band. Okay, yan din yung mga electrons that is responsible for the bonding of your atoms, your valence band. Now, take note, just above the valence band, you have your conduction band. So ang tendency ng mga electrons, once they get energy, is from valence band, they will jump to your conduction band. Okay? And because nasa conduction band na siya, it can freely move now. And that's the time na nagkakaroon ng conduction of electricity. Kasi may movement na. Free movement na yung electrons. Free na yung electrons ko to move. Okay? So that's the idea of the band theory. Now, ano yung, bakit si insulator hindi? Bakit si semiconductor may conditions pa kailangan abutin para mag-conduct ng electricity? So, dito yung papasok. For metals, so yung makita yung unang figure sa inyong left, that's actually yung valence band mo, just right after the valence band, you have your conduction band above. Okay? So, it's easier now for your electrons to jump towards the conduction band. Okay? That's why metals tend to conduct electricity. Okay? Now, pagdating sa semiconductors, sa inyo nasa gitna ng figure sa inyong screen, okay, semiconductors, meron tayong maliit na energy gap. Sa energy gap na to, you need actually an amount of energy for your electron to jump from your valence band to your conduction band. So yung idea is, dahil sa maliit na gap na yan, kailangan nyo yung electron ko dito, kailangan niya ng energy para tumalon papunta sa conduction band. That's your energy gap. That is the reason why semiconductors needed to be heated. Most of them need to be heated para mag-conduct lang ng electricity. The reason is, pag nilagyan mo sila ng heat, magkakaroon kayo ngayon ng electron ng energy. Take note, heat is synonymous to energy, para mag-jump to the conduction band. So that's how semiconductors conduct electricity. So semiconductors can conduct because may certain conditions na inaabot. Pero pagdating sa mga insulators, as you can see there, malaki yung energy gap between the valence band and the conduction band. So makikita nyo dyan yung malaking energy gap na yan. So it will be hard for your electrons now to jump. Kahit may makuha siyang energy, malaki yung amount na energy na needed niya para maka-jump from the valence to the conduction band. That's why insulator, bibihira silang maka-conduct ng electricity. Pero there are certain conditions na pwede. Pero sabi ko nga, they should overcome first the energy gap. So hindi siya madadala basta lang ng Milo. Sorry, pero hindi sponsored itong video na to. Okay? So I do hope na malinaw yung pagdating sa conductivity or electrical conductivity ng metals, semiconductors, and insulators. Okay. So as a summary, the mechanical properties of materials are hardness, brittleness, ductility, plasticity, elasticity, malleability, and toughness. And in this video, we discuss each of them. Okay? We also have properties of a metal are the characteristics by which it can be accurately identified or by which its range usefulness can be determined. So that's all for this video. I hope you learned a lot, especially regarding the mechanical properties of materials. But just remember to keep calm and love chemistry. See you on the next video.